How can we find the value of a, which will make this polynomial expression ax squared plus 9x minus 4 exactly divisible by x plus 4? Now, these are the options for the possible values of a. Now, suppose we let this polynomial expression be denoted by p of x. That is, p of x is exactly ax squared plus 9x minus 4. Remember that if I have a polynomial expression that is divided by a linear factor, x plus b, for example, and on setting this linear factor x plus b to 0, we will obtain that our x is exactly minus b. And on substituting these values of x, or the values of x in the given polynomial by minus b, we are going to obtain that our p of minus b is exactly the remainder that we will get when this x plus b divides the given polynomial. Now, for this polynomial to be exactly divisible by x plus 4, it means that the remainder is 0. And on setting the linear factor x plus 4 to 0, we will obtain that our x is exactly minus 4. This means that when we replace this x's here and the given polynomial expression by minus 4, we are going to obtain all this expression to be 0 because the remainder here is 0. That is to say that p of minus 4, which is exactly a into minus 4 squared plus 9 into minus 4 will exactly be 0 because the remainder is 0. Now, this reduces to minus 4 squared, 16a, then plus 9 times minus 4 will give us minus 36 minus 4. All this will give us 0. And we have that 16a minus 36 minus 4 will give us minus 40. All this will be 0. And this will then imply, on collection of like terms, that our 16a is exactly 40. That is when we must have added 40 to both sides of the equation. And on dividing this equation using the coefficient of a, which is 16, we obtain that our a is exactly 40 divided by 16, which is exactly 2.5. And so the correct option here is D. This is how we use remainder theorem to solve similar questions such as this. Bye.